Hello, welcome to this talk. I'm Xiao from the Data System Group at MIT CCL. The title of our paper is Atlantic, Making Database Privacy Preserving and Faster. This is a joint project among MIT, Google, Facebook, and Tsinghua University. Atlantic is our most recent project. We built Atlantic with our Google and Facebook collaborators to make database privacy preserving and faster. Many organizations are collecting and analyzing sensitive information about individuals. For example, in our medical AI project, joined with Massachusetts General Hospital, or in short MGH, which is one of the top hospitals in US, we use patient information such as their age and gender to discover the correlation, for example, between age and the possibility to get seizures. Seizure is one type of brain diseases. This sensitive private information often is stored in relational database, allowing users to easily conduct data analytics through SQL queries, in particular aggregation. However, the analytics result potentially disclose individual sensitive data to users, causing privacy leak. If the organization does not want to disclose individual sensitive data to users, SQL queries must be privacy preserving. Differential privacy is a promising technique that automates general statistical analytics of data while protecting information about individuals with a strong guarantee of privacy. In general, it protects the data privacy by injecting noise into the query results. Differential privacy has received growing attention from organizations including Google and Apple, and from the database research community. However, differential privacy for general purpose SQL queries remains an open challenge. First, most of the existing solutions require substantial modification to the underlying database engine, complicating adoption in practice. Second, the existing solutions often introduce heavy computation overhead due to, for example, computing privacy sensitivity of the query. Third, the existing solution often have to inject large noises to protect the data privacy, thus leading to low accuracy of query. Our Atlantic solves about problem. First, it runs as a middleware layer. More specifically, it sits between the user and the database. Given a user query, Atlantic rewrites the query to collect the statistics required as the input to the differential privacy mechanism. After query results come back, it runs the differential privacy algorithm to add noise on the result and return the result to analysts. It is compatible with real database systems such as Postgres, MySQL, Spark SQL, etc. It supports queries expressed in standard SQL and thus easily integrates into existing data environments. Second, wherever possible, Atlantic executes queries over a set of samples pre-computed from the data. It leverages the key insight, which we call privacy amplification of sampling. This means when running a query on a random sample of a given dataset, the differential privacy mechanism is able to provide the same privacy guarantee while injecting less noise into the query results compared to running the query on the complete dataset. More intuitively, it will be hard to guess the individual information from the query results if they are produced from samples. As a result, Atlantic offers orders of magnitude faster query execution while achieving the same guarantee of differential privacy and even better query accuracy. As far as we know, it is the first system that enables differential privacy for general purpose SQL-based analytics. And thank you. I'm happy to take questions.